Again, you guys should have your 3 sheets of blank paper and a marker. We're going to make a book that is going to help us to organize our notes on factoring. So we need to make the book first thing. So this is what we're going to do. Let me show you what we're trying to get it to look like. That may be helpful. This is eventually where we're going to get. We're going to make one of these. Okay? Each of the different tabs in our book will have some factoring examples under it. Alright? But we need to make this. So to do that, I'm going to take my sheets of paper. I've got 3 of them. I'm going to use different colors. It's kind of hard to tell when I use all the same color on here. So I'm going to take my 3 pieces of paper and I'm going to try to space them out evenly. It doesn't have to be perfect, so don't worry if it's not. Okay, so I've got my 3 pieces of paper that I've spaced out evenly or as close as I can on the bottom. And then I'm going to take my 3 pieces of paper and I'm going to fold it over. So it'll make those tabs that we want. Okay. See what I did? Fold it over. Once you've got them spaced out, we're just going to fold them over so that you make 3 additional tabs and you have another space in here. And then wherever we get it, just put your crease in it. You guys have questions on looking at our books? I would take this side here. Let's see here. Let's do this. Let's make this. So you're going to have all these nice little tabs. You can put your crease in wherever you want to put it, okay? Is it okay? Everybody okay? Making their book? Okay. Now to hold it all together, I'm going to pass around the stapler. You can put a couple of staples here on the top to hold it. Staples here and here. Put a couple on it just to hold it together. Do make sure you try to go through all the pages. Looks like I missed a couple of pages when I went through my stapler. I have too close to the edge. Okay, while you're waiting for the stapler to come around, let's go ahead and label. We're not going to label everything just yet. We're going to do it as we learn it. So to title it, let's put factoring polynomials on the top cover. If you've got a permanent marker, we'll bleed through. So you're going to want to put something underneath it. You do have a permanent marker. So factoring polynomials. Now, we're going to learn one method of factoring today. We're going to work on this for a few days. That method is called greatest common factor. So here on this next tab, if you would put greatest common factor. So here's my plan, is that when you open it up, we can put all of our examples for greatest common factor on these pages right here. That's all you need to label for now. We'll get the others as we fill in. How are we doing? We get our book set up, we have it titled, and then we should have the first tab marked as greatest common factor. I said factoring polynomials. Has everyone had a chance to staple? While we're waiting for that to finish up, go ahead and open today's lesson. Thank you. So there's a couple of things that we're going to do in this section, and that the one thing being is we're going to use the distributive property to factor polynomials, which a lot of times we call this greatest common factor. That's going to be our focus for today. And we'll also learn how to solve some equations that we have factored using greatest common factor. Let's see if I can get this screen. I'm giving you a picture here of some animals. What do these animals have in common?
They're animals.
I gave you the answer, didn't I? These all are animals, right? That's what they have in common. When we're looking for our greatest common factor, that's what we're looking for. That they're all what they have in common. In our case, they're animals. How about these objects? I should be more careful with my words. What do these objects have in common? They all fly. Okay, all fly. How about here? What if I give you two numbers and I said, what is their greatest common factor? 12. How'd you get that, Chris?
Well, honestly, I just said 12.
What was a good guess? You can divide them both by 12. Is there a bigger number that you can divide them both by? Let me ask you, is there another number? Not necessarily a bigger number, but is there another number? What could it be? 2. I heard 6. Is there anything else? 4. Now, but I'm asking specifically for the greatest, right? Not just a common factor. I'm looking for the greatest. So 12 would definitely be that number because 12 goes into both 24 and 36. What about this? 5a and 35. 5. Do you agree that 5 goes into 5 and 5 goes into 35? So we would say here that our greatest common factor would be the number 5. What about this? Huh? Why? How did you get why? It's in both, isn't it? Now, there's nothing that goes into 3 and negative 8. But we do have something that goes into the variables y. We take a y out of both. How about this one? Negative what? I agree with the negative. I disagree with the 2.
Negative 1.
Okay, negative 1. What else? X what? Close. Huh?
Negative x2.
How do we say? We don't say negative x2. What would we say? Negative x. How do we say it? You just say it.
Oh, squared.
Yeah, negative x squared. Our greatest common factor here would be negative x squared. Do you see that all 3 of those terms are negative? So we can take a negative out. They all 3 have x squared, right? So we can take an x squared out of all 3 of them. So we would say that our greatest common factor is negative x squared. All right, so let's go ahead and we're going to go through this process. If you would like to put some examples in your book, that may be very, very helpful. Okay? I'm going to do my problems on the board, but feel free to do your examples in your on your factoring book. Now remember, I would open your front tab. And you're not going to want to write huge because if you're going to put several examples in here, right? So write as much as you can or want to in here. Don't write really big. You're probably not going to want to use your marker either. You probably want to use your pen or pencil. So the first thing we need to know is, what is the largest number which goes into both 16 and 12?
4.
4. Very good. 4 goes into 16 and 4 goes into 12. It's the biggest number. So that is what we're going to start with. Now, what variable goes into both x cubed and x squared? You can take an x out, but think of x cubed. How many x's do we have here if it's x cubed? 3. We say that's x times x times x. How many x's are here if we have x squared?
2.
Okay. I want to be able to take an equal number, or the most that I can take out of both of those x expressions. How many can I take out of both? I can take 2, but 9. I can take 2 out of the first one. I can take 2 out of the second one. Could I take 3 out of both? No, I can take 3 out of the first one, but I can only take 2. So the greatest I could take out of both is 2. So we would write that as x squared. Now, how are we going to write our answer? Well, 4x squared is, we say, the greatest common factor. So this is how we're going to write our answer. We have the 4x squared. And then we're going to have parentheses. In parentheses, this is what we have left when we divide. Okay, when we divide. We've divided monomials before, correct? Yes. So we're going to divide by 4x squared. Excuse me. So, yeah. Yes, I am. Thank you for writing. 16 divided by 4 is 4. That's where this 4 came from. I divided. I had x cubed divided by x squared. What is x cubed divided by x squared? X. So I have 4x. Minus. Here I have 12 divided by 4, which is 3. And x squared divided by x squared is? Well, they cancel out. Okay. So this is how we're going to write our factored answer. That's how we're going to write it. I'm going to go through a lot more examples with you here. Look at example 2 up here. It says to factor each polynomial. So go ahead and jot this down into your factoring book. We have 27y squared plus 18y. So I'm just looking at example 2 for right now. Let's ignore example 3. Looking at 27 and 18, what's the greatest number that goes into 27 and 18? Now 3 goes in, but that's not the biggest. What's the biggest? 9. Now guys, this is where you're going to get in troubles if you don't know your multiplication facts, aren't you? Okay? You've got to know what numbers go into 27 and 18. Well, the biggest number there is 9. So we're going to write 9. Look at your variables. I have y squared and I have y. So really y squared is y times y. I have y. I need to take as many y's as I can out of both, but it has to be an equal number. How many y's can I take out of both? I can just take one, can't I? I can take one of these y's, and I can take this y. So 9y. Now in parentheses we're going to write what we have left when we divide by 9y. Well, what is 27 divided by 9? 3. What is y squared divided by y? Y. 1y or just y. What is 18 divided by 9? 2. So it's plus sign here. So we're going to bring our sign down. Plus 2. And y divided by y? They're going to cancel. So this expression right here is my factored answer. Is there an easy way that we could check to make sure that it's right? So you can distribute. And you can even just do this mentally. You don't have to write anything down. But if we were in our heads to take 9y times 3y, what do we get? 27y squared, what we originally had. If we take 9y times 2, what do we get? 18y. And that's just an easy way. You don't have to write it down. Just mentally check yourself to make sure you distribute it or you factor it correctly. Look at example 3 here. I'll give you a second to copy this into your notebook. You may remember a map, but when we get all these other methods in there. Now, a rule that I haven't told you about is if we're factoring, and the first term of our polynomial is negative, whatever we factor out is going to be negative. Okay? Our first term is negative, so we know we're definitely going to take out a negative something, right? Look at your coefficients. What goes in, or what's the greatest common factor of 4, 8, and 2? 2. Everybody agree with 2? Now let's go through our variables. Here we have a squared, so we have a times a. Here we have a, and here we have a. How many a's can I take out of all of those? 1. I can just take 1. So we'll write this as negative 2a. Go to your b's. Here I have 1b. Here I have 2 b's. Here I have 1b. I want to be able to take an equal number out of all of them. What can I take out? 1 of the b's. So I have negative 2ab. Now in parentheses, we're going to write what we have left when we divide everything by negative 2ab. So negative 4 divided by negative 2 is positive 2. A squared divided by a is a. And the b's would cancel. I have negative 8 divided by negative 2, which is 4. So plus a positive 4. Because a negative 8 divided by negative 2 is a positive 4. Well, a divided by a is going to cancel. B squared divided by b is b. Go to your last term. I have 2 divided by negative 2. Negative 1. So we do need to write that in. Got to write that in. Negative 1. A divided by a, cancel. B divided by b, cancel. So this here would be our factored form. If you guys want to write any notes to yourself in your book about how you got something, feel free to do that. Okay, this is for you. This book is for you. How about example 4? I'll let you copy that down. 15w minus 3w. Excuse me, 15w minus 3b. Starting with our coefficients, 15 and 3. What goes into 15 and a 3? 3 does. I have a lot of people that will want to say 5 here. They'll just take 15 divided by 3, but be careful. We want to know what goes into 15 and 3. That's 3. Look at your variables. I have w here. Do I have any w's in the second? No. I have a v in the second. Can I take a v out of both? No. Can I take a wv out? No. No. I don't have anything other than a 3 that they have in common. So in parentheses, let's write what we have left when we divide by 3. So 15w divided by 3, or 15 divided by 3 is 5. So we have 5w. Negative 3 divided by 3. Negative 1v or negative v. And that's all we can do. No, you do not have to put a 1. That should be sufficient. Let's look at another one. Example 5, I'll give you a second to copy it down. let's start with our coefficients. We have 7, 21, and -1. Now hang on, 7 goes into 7 and 21. Does 7 go into -1? Can I take -1 divided by 7? Not take it evenly. What are you thinking? 1. That's it. 1. As far as the coefficient is concerned, it's 1. Now let's go through our variables. Here I have u times u. Here I have a u, and here I have a u. So what can I take out of all three? 1u. How many t's? I have t and t, t and t. I have a t. I can only take one t out as well, right? So I have 1 ut, or just ut. So in parentheses, let's write what we have left when we divide by ut. So 7 divided by 1 is going to be 7. What's u squared divided by u? U. And t squared divided by t is? T. I have 21 divided by 1. 21, so plus 21. U divided by u? Cancel. T squared divided by t? It's t. Here I have -1 divided by 1. -1. U divided by u? Cancel. T divided by t? Cancel. This would be our final answer. Now instead of saying 1 ut, what could we say? Ut. I want you guys to try the next one. Go ahead and put it in your factoring book so you'll have another example that you can reference later. Let's do example 6. Example 6. When you think about it, let me know so I can look at it. Who needs some help? guys got that. Good job. Okay, I am going to alter the assignment that's on the board a little bit. We're not quite ready to do all of those. So give me just a second. If you are afraid that you're going to lose your factoring book, you are welcome to leave it in here. If you want to leave it in here, I can hold on to it for you. If you want to take it with you, that's fine, but just don't lose it because you're going to have a lot of good stuff in there. You may. All right, we are...
Did you already stop the recording?
Not yet. Page 480, numbers, let's do 15 through 26. It's all using greatest common factor. Wait. I'm sorry, hang on. 25. No, can't do that. Sorry, I have to change this again. I tried to do this spot on and it didn't work out quite like I wanted it to. Okay, so some of it's on 479 through 480. Let's do 1 through 4 and 15 through 20.